All right, in this video we will check out how to take the nth root. So now we will wrap up all the operations with polar forms of these complex numbers. All right, again, this is attributed to the work of de Moivre, or however you say his name. I have the formula in the upper right, as I did for the other topics on this section. So nth root of z, which another way of writing that is z to the 1 over n power, right? That's just algebra notation. So what we do is we take the r and the nth root of r, right? R to the 1 over n. And then the formula I think will make better sense with an example. But the n, some of it, I mean, is pretty straightforward. But we take the angle theta and we divide by whatever nth root we're doing, all right? But we're going to have multiple answers. So this first example where I said find the fourth roots of 1, that means there are 4 complex roots of this number. Now, besides 0, that's the only exception. But any other complex number, if you take a fourth root, there will be 4 solutions. If you take a square root, 2 solutions. 10th root, 10 solutions, all right? So this k is going to generate, right here, that k is going to generate all the values from 0 up to 1 less than whatever root you're doing. So what that means is for this fourth root, I would plug in 0, 1, 2, and then 3 because 4 minus 1. Right? If I'm doing a square root like the second example, I will only plug in 0 and 1 because square root is a 2, right? 2 minus 1 is 2. I'm sorry, 2 minus 1 is 1, geez. Talking quicker than my brain is working. All right, so you'll always have that many solutions, and you start with k being 0, which essentially would wipe this out for the first one always. But then you'll substitute k as 1, 2, 3, and so forth. All right, let's take a look at an example. So what I'm going to do first actually is show like sometimes, right, like you don't have to use this formula. It will work. But let me show the idea behind it. So to find the fourth roots of 1, that would be equivalent to me saying like solve this, right? Because then I'm going to do the fourth root on both sides. Let me get one more color up here. Fourth root, fourth root. But fourth root of 1, like all I see in my head is, all right, probably like 1 and negative 1, right? So, I mean, how do you do that? All right, so let's take a different approach. If we were to say x to the fourth minus 1 equals 0, right, subtract 1 on both sides, and factor x squared plus 1, x squared minus 1. Now set each factor equal to 0. And we could factor this right side again, x plus 1, x minus 1, but it's all right, we'll solve them both the same. So now when we take the square roots, remember you need plus minus, right? So x equals plus or minus 1. X equals square root of negative 1 is I. So x equals plus or minus I. So there are 4 solutions. 1, negative 1, I, and negative I. Graphically, I want to show this really quick. Graphically, we could find these solutions as well. Once you know one solution, we can visualize what the others will be. All right, here's how it would work. I know one of the roots of 1 is 1, right? So this is a solution. Because there are 4, what this 2 pi k over n graphically is doing is saying split up 2 pi into n pieces. Well, I'm doing the fourth root, right? So if I split this circle into 4 to find all 4 roots, then, and I'm at 0 here, then I would need a point here, and a point here, and a point here. Well, that makes sense because in the complex plane, right, A and B, this point here is 0 plus 1i, so it's I. and there's negative 1, and then here is negative I. All right, but now if I had changed this example to, all right, that works, find the cube roots. Find the cube roots of 1. Well, graphically, I think it's not horrible. It's going to take a little bit of creativity here, but if I were to start with my first solution here, and then split up 360 into 3 pieces, right? Then in degrees, it's a bit easier to see. I would need 120 degrees, and then I would need 240, which is about here, right? And now it's split into 3, but the challenging part is I need the radius, right, the R, to be 1. So I need to go out 1 unit here and 1 unit here. So I don't really know what those points are quite yet. It would take some work, right? But we could. So let's look at that one last, and I just want to apply this formula on this example because most problems you encounter will in fact look like this example on the right here. Okay. So let's apply the formula, and then we'll go back and jump to that cube root of 1 and see what those other points are. All right, the formula says to take your R, this is still R, right? And I need to do the square root because that's what I'm taking. I'm taking the square root. Square root is the same as saying to the 1/2 power. Right? So our roots are going to be z, so square root of z, or z to the 1/2 is the same as saying square root of 16 times cosine, so I have 100 degrees divided by, now n is 2 because I'm doing square root, right? So n is 2 plus 2 pi k, so plus 2 pi k over 2. And then I also know whatever I get here, right, it's going to be the same for the I sine plus I sine of that stuff. I'm not even going to rewrite it because we usually change it to the CIS form anyways. Okay, so let's go ahead and simplify that a little bit. Square root of 16 is 4. Cosine 100 over 2 is 50 degrees. And then 2 pi, so I know I'm in degrees. I meant to change it before, but 2 pi is the same as a full circle, right? It's 360 degrees. So rather than leaving it as 2 pi when this problem is clearly in degrees, we could change that to 3. Oh, I don't know why I did that. Undo. We could change that to 360. So think 360k divided by 2 is 180k. Okay. And then again, we get the same for this I sine. I'm going to be lazy. Instead of writing 50 degrees plus 180k, it goes there too. All right, now we're doing square roots. So I'm going to have 2 answers. So what we do first is we let k equal 0. Okay, and then we'll simplify and we'll get our first answer. And then we'll do k equals 1. And then we'll simplify and we'll get an answer. And those will be our 2 square roots of the polar form z equals 16 cosine 100 degrees plus I sine 100 degrees. Okay, let's do it. All right, if k is 0, we get 4 cosine 50 degrees plus 180 times 0. Right? I probably don't even need to write that, but I'm going to go ahead and do it just to show all the work. Plus 180 times 0. So how about for I sine? We already know that result. Instead of saying ditto this time, I'll just write the 50 because that's what it reduces to. And 50, again, depending on how they want the answer, usually we just leave it in polar form, like we want the nth root in polar form, but it does depend, right? Like the first example we did, I wrote it, the four solutions as 1, -1, I, and -I. I didn't change it to polar form, but this one, because it's 50 degrees and we're in polar form, odds are we're good with just leaving it in polar form. So the first solution is 4, and then we'll go ahead and change it to that notation, CIS 50 degrees, right? Because the 180 times 0 is 0. All right, now let k equal 1. So 4 cosine 50 degrees plus 180 times 1, okay, plus I sine, and 180 times 1 is 180, plus 50 is 230. We'll go ahead and simplify that now. I noticed I have an extra parenthesis here. I'm just deleting that. Clean it up. Okay. All right, and again, 230, it doesn't have any exact values. I would have to use a calculator, and if I wanted it in a decimal approximation, I could. But usually, again, we just leave it as 4 CIS 230 degrees. So looking at that original problem, right? Find the square roots of 16 CIS 100 degrees. I wouldn't know that these are the two solutions there. Okay, and that's how we are using polar form and this nth root theorem. All right, cube roots of 1. Let's start this from scratch rather than trying to visualize and get a graph of it, though we could do it at that approach. Let's write it in polar form and then apply the formula. So 1 is the same as 0 plus I, I'm sorry, 1 plus 0i. Ooh, forgot I was on highlight. 1 plus 0i, okay? And polar form then is, the angle we know is 0, right? So r is 1. The graph of 1 is just right here. So we know r is 1, and the angle theta is 0. So let's write that up. Z equals 1, which I don't need to write, CIS 0. Okay, I'm going to leave 0 as a radian. I'm not going to write 0 degrees because I want to use the 2 pi kn formula. Okay, and most often we deal with radians, as you've seen throughout trig. Sometimes degrees pops up and it is easier to visualize, but usually radians. Okay, so formula time. We go, let's do pink. The cube root of z, so cube root of z, right, is equivalent to, we write z to the 1/3. So r is 1, so cube root of 1, don't really need to write that, I know it's 1. Cosine, okay, theta over n, 0 over 3, plus 2 pi times k. You would think, oh, it's 0, the whole thing is going to be 0. Not necessarily, right? Just this initial one is 0. Because now I have 2 pi k over 3. And then plus I sine, of course, I'm going to get that same stuff. Be a little lazy there. All right. So reducing that, we just have 2 pi k over 3, right? So we get 1. Again, I really don't need to write that. Cosine 2 pi k over 3 plus I sine 2 pi k over 3. All right, now we have 3 solutions. We need to let k, let k equal 0. That's going to yield 1. Let k equal 1. That'll yield another. Let k equal 2. You always stop at 1 less than what root you're doing. Since we're doing cube root, right, I stop at k equals 2. All right. Now, I don't have anything, right? This simplified pretty nice. This was a 0. That won't always be the case, but I don't really need too much room here because this is pretty easy to plug in my k. So I just get k is 0, right, for the first one. That's going to be, and I don't even need this 1, so that's going to be z, or the first root, so not z, we're doing a root. Okay, one of the roots is just cosine CIS 0. Right, I plugged in 0 for k. Now I plug in 1 for k, so the second root is going to be CIS 2 pi over 3. Right, k is 1. The third root, plug in 2 for k, I have 2 pi times 2 is 4 pi over 3. All right. Now, I had said above when we first started, maybe it would be a bit of work to visualize. Now that we have the answers, okay, maybe not, right? Because we actually knew r. R was 1. Because I knew the first root, the cube root of 1, right? Mathematically, I knew it was 1. And therefore, that distance had to have been 1. Therefore, I knew r was 1. If we thought about it just a tad bit more, we probably could have derived all 3 of these answers. But that's okay. 2 pi over 3 in degrees is 120. Right? This angle, 2 pi over 3 up here, that's equivalent to 120 degrees. 2/3 of 180, right? And then the last one here, 4 pi over 3, is equivalent to 240 degrees. So these answers, again, they make sense. I wanted to take a real solution that's tangible, right? Like, I don't know cube root of 1 off the top of my head. I know one of the solutions is 1, but I don't know the other 2 complex solutions. So we really broke it down how to go from there all the way through, but also I gave you an example in which it's already in polar form and how to exactly use that formula from the start.